Hello everyone. Today we are going to learn about parity generator and checker using IC 74280, and also we are going to learn about how to write a VHDL code for this parity generator and checker. In digital systems, the parity bits are used to indicate the number of ones in a given digital word. There are two types of parity, even parity and odd parity. If you consider an example, a data word, all ones, 1111, 1111. Here there are 8 number of ones. Therefore, this data word has even parity 1 and odd parity 0. And now this functionality is implemented with an IC named IC 74280. IC 74280 is a parity generator and checker. And this internal structure of this IC has two different types. One is tree structure and daisy chain structure. And these parity generators use all exclusive OR gates in the design we know already, right? So the internal structure contains tree structure or daisy chain structure with all exclusive OR gates. Before going into those details, let us see the pin description of this IC 74280. It is a 14-pin IC. 14th pin is VCC and 7th pin is ground. And the third pin is no connection. It is not used. And D0 to D8, we have 9 input data word, 9-bit input data word. And it will accept from 1 to 4 and then 8, 9, 10, 11, 12, 13 pins. And 5th and 6th pins are used for even parity and odd parity. And pin 7 and 14 supply pins, we say power supply pins. Now let us see the tree structure of this IC 74280. It is a parity generator and checker, and it is having these many what is that exclusive OR gates. Okay, so exclusive OR gate 1, 2, 3, 4, 5, 6, 7, 8 exclusive OR gates are used here. It is a 9-bit parity generator and checker. So D0 and D1, all 9 ones are applied at the input of this parity generator. And if you observe the output of each one of these, let us see what is the parity of this 9-bit data word 11111111, right? 1 and 1 are applied to this exclusive OR gate, therefore output is 0. So when both inputs applied are same, output is 0. Therefore here also 0, here 0, and here 0. And D8 is applied to the last exclusive OR gate in this tree structure, and output of this gate and this gate, these two outputs are applied to next gate, that is X5. So 0 and 0 are same inputs, therefore output is 0, and 0 and 0 output is 0, again 0 and 0 output is 0, right? And the output of all these exclusive OR gates, final output is 0, and this is 1. So 0 and 1, the inputs are different, therefore output is 1, therefore odd parity is 1. And not of odd parity is even parity, it is 0. So from this structure, even parity is 0, odd parity is 1. And we know that out of 9 ones, 9 bits, 9 are ones, therefore odd number of ones are there, odd parity is 1. And similarly, we can see the daisy chain structure of this same IC. So daisy chain means output of first exclusive OR gate is given as input to the next gate, and like that in this manner, right? So therefore, we can see D0, D1, 1, 1, output is 0, and D2 is applied here as 1, and 0 and 1, output is 1, and this one is applied, and 1, output is 0, this one is applied, and 0 and 1 inputs are different, therefore output is 1, and D5, 1 is applied here, both inputs are same, 0, and inputs are different, inputs are same, 0, inputs are different, 1. So odd parity is 1, even parity is 0. So in this manner, we can understand the internal structure of this IC 74280, just similar to the previous case. we can say even parity is 0 and odd parity is 1. Here also even parity is 0, odd parity is 1. Right? I hope you understand these concepts, and if you understand, please like, share, subscribe and comment in the comment section. Right? Now let us see the VHDL code. VHDL code for this parity generator and a library IEEE. This is library declaration with these two lines as we know, and entity declaration. And in entity declaration, we write entity, name of the entity is, and what are the input ports. D0 to D8 are the input ports. They are of standard logic type. And even parity and odd parity are the output ports. They are also of standard logic type data. And then end parity gen, I'm writing here, you can give your own name. So entity declaration and library declaration are over, and then we have to write architecture body. So when we write architecture body, we can write in different styles of modeling, and here I have considered the structural style of modeling. For convenience sake, I am using this logic diagram here. I placed this logic diagram here, right? So you can write the data flow style and also behavioral style. We are following now the structural style. Architecture, parity generator, structural style is the name we are giving here. You can give any name here in the architecture to the architecture, and architecture, name of the architecture of which entity, that is parity gen is the name of the entity, is component. And here we have used all exclusive OR gates, therefore XOR gate. And a component declaration and signal declarations we have to declare before we write the begin statement in the architecture body. Therefore, we are writing component declaration here, component XOR gate. And before we use these components, one thing we have to ensure that components used in the architecture, they may be the ones that were previously defined as part of the design. Otherwise, they should be as part of the library, right? So then only the program will understand. So component XOR gate and port X comma Y are the input ports for the XOR gate with the standard logic data type, and Z is the output port with the standard logic data type. End component. Okay. Now the signals, intermediate signals, we are using S1, S2, S3, S4, S5, S6, S7. Therefore, all these signals, they are also of standard logic type we are defining. Now let us say the architecture begin, and X1 is what? X1 is the exclusive OR gate with the XOR gate port mapped with this D0, D1, S1. So X1, XOR gate here we have given the names X, Y as input and Z as output. And now in our design, D0, D1 are the inputs and S1 is the output. Therefore, X1 is XOR gate port map with D0, D1, S1. That means X is port mapped with D1, D0, Y is port mapped with D1, and Z is port mapped with S1. Similarly, what is X2? X2 is XOR gate port map with D2, D3 and S2. So D2 means X is port mapped with D2 and Y is port mapped with D3 and Z is port mapped with S2. So like that, X3 port map with D4, D5 and S3. X4 port map, XOR gate port map with D6, D7 and S4, and X5 XOR gate port map with S1, S2 and S5, and X6 is XOR gate port map with S3, S4 and S6, and X7 is XOR gate port map with S5, S6 and S7, and X8 XOR gate port map with X8 XOR gate port map with S7, D8 and odd parity. So like that we complete the architecture body, and even parity is not of odd parity bit, and end parity generator structural style. In this way we can develop a VHDL code for 9-bit parity generator and checker using IC 74280 in structural style. So this is the complete program: library declaration, entity declaration and architecture body, right? Hope you have enjoyed this lecture. And if you understand, you please like, share, subscribe, and comment. Thank you.